Hi everyone, it's Dr. Tracy. And this week we are working on control statements. Control statements are ways that you can loop through code or make decisions with code by changing what statements are executed according to Boolean conditions. So this is a big topic and it covers 2 weeks, and everything for those 2 weeks is on this same page. You can see that there's a discussion for this week and there's a discussion for next week. There's one assignment and that's going to cover 2 weeks and count double. And there's also one quiz, which is going to cover 2 weeks and count double. So I'm going to go over part of it today. I'll talk about some loops and some if statements, and then I'm going to finish up the rest of it next week so you know where to get started. And actually, I'm going to go into this conditions tutorial right here for learnpython.org. The first half of control statements is making decisions. And so in this conditions tutorial, it uses Boolean variables to evaluate conditions. Conditions are anything that evaluates to a true or false in Python. For example, if I say x equals 2 as a statement, we know that that in Python sets the variable x equal to the value of 2. But then if you say print x is equal to 2, two equal signs, as we learned in the last chapter, means is equal to. So that basically is just determining the condition. X is equal to 2, that's a true statement. X is equal to 3, that's a false statement. X is less than 3, that's a true statement. And so you can see where Boolean conditions are and how they are evaluated by clicking run on this first set of code. And the workspace shows true, false, true. But this is considered a Boolean operator, is equal to, or also less than. And looking at the various conditions of Boolean operators, we can use less than, greater than, equal to, not equal to, greater than or equal to, less than or equal to. And so in this and or examples, we can combine multiple Boolean operators to produce compound decision making. And there's an if statement right there. If the name is equal to John and the age is equal to 83, and so that's how you read line 3. If that happens, it will print your name is John, you are also 23 years old. But if the name is equal to John or the name is equal to Rick, it will print your name is either John or Rick. So in this if condition, the structure for setting up an if condition is to have an if statement and then to have a Boolean condition to test that uses a Boolean operator, and then indent, and then have the statement to execute if it's true. So if I run this code, your name is John, you're also 23 years old. And this just shows you that if the age were 24, that first line would not print. And if the age were Johnny, we're not going to get anything the next time that it runs, which I didn't. And so that's just a way to check. Now there's also an in operator, and an in operator can be used to check if a specified object exists. And that is unique to Python. Not all languages have that. And so here is another example of using the if statement. If statement is true, it will do something. Now, if we have another condition that says that statement is not true, but I want to test for something else. If that statement is true, it will do something. But if it's not true, it's going to skip down to line 6 and execute else if. ELIF is Python equivalent of else if. That means given that the above statement is false, is this statement true? And then it will do that statement. Now, if the first statement is false and the second statement is false, it will skip down to 9, and that is a default else. Else colon indicates that that will be executed if it never hits another value. So there's an example of using an if statement. If x is equal to 2, then print x is equal to 2. Else print x does not equal 2. If I run it right now, I can tell that my if condition says x is equal to 2. But if I change that to 29 and try and run the code, x does not equal 2 because it doesn't equal 2 anymore. There's a few other operators that are used to test Boolean conditions and make decisions. For example, the is operator. It does not match the values of the variables, but instances themselves. So that way that if we have instance or a set of numbers, we'll say, is it true? Are they exactly the same, or do they match in an instance? And the not operator, which means the opposite. Not false is true, and not false is equal to false, prints out false, because they aren't the same. That can get confusing. Let's take a look at the PowerPoint for this week. The PowerPoint shows control statement. And it goes through a few different instances of kinds of control statements that you would use. So it talks about the for loop, and I'm going to reserve the for loop for next week. And I'm going to skip past that. That's why I started with the if statement. But getting into loops, it's still a decision to make. And so I'm going to move down to after the case study, to right here, for if and if else. So this is starting on the 21st slide of PowerPoint. I'm going to hit all of it, trust me. I'm just going in a different order than they went. Yours might be kind of separate from this too, but this will give you a good idea. These selection statements are based on a condition, and that condition is using the Boolean type, comparisons, and expression that evaluate to true or false. Equals, not equals, less than, greater than, less than or equal to, or greater than or equal to. The if-else statement, as was shown on that tutorial, has an if statement, a condition to test. In this case, area is greater than 0. Everything that will be executed if that Boolean statement is true would be indented 4 spaces or press the tab key. And if that is not true, if the area is not greater than 0, it will print area must be a positive number. So the syntax for an if-else statement is if, Boolean condition to be evaluated, colon, the statements that will be executed if it's true, outdent to else, colon, indent, sequence of statements to be executed if it is not true. If you look at this visually, then we have a Boolean expressions to show what happens if the first if statement or Boolean expression is evaluated to true, and what happens if it is evaluated to false. There's also one-way selection, which is when you say if something is true or not, you can execute it without having to execute something that's false. And we can also write them simplified. You can also have multi-way if statements. A program might be faced with testing multiple conditions, and if so, that's where we would include the else if. This is a multi-way else if statement showing if condition, sequence of statements, else if condition, sequence of statements, and else being the catch-all if it doesn't fit anything else. So if we had those selection statements in the basic of if, we can put them all together by combining them. So, oops, I'm doing page up. I meant to go down. So that kind of explains what the multi-way if statements are and shows how we can use if else, and if else in order to make decisions if something is true or not and change the control flow of the program using logical operators and Boolean expressions. Hope that helps.